Determinants. I don't know who's used matrices before. This is just a refresher or perhaps brand new. If I have an array of numbers, just a single number, let's just say 5, then the determinant is just equal to that number. This is not an absolute value. This is a determinant. So if that number were -5, sometimes DET will be written in front, but it should be understood most of the time. That's going to be equal to -5. If I have a 2 by 2, so the determinant of a 2 by 2, so if I have 1, 2, 3, 4, the basic technique is I start somewhere. And there you can, officially you can start anywhere you want and go through it that way. There are some really convoluted ways of doing this. I'm going to just do it one way, and if you want to do it a different way that's correct, go for it. But I start in the upper left-hand corner and I write that number down. I sort of block out that row and column, and what I'm left with is a 4, so that's 1 times the determinant of 4, minus, because as you move across, you alternate signs. Then I go to the next number, 2, and block out that row and that column. What I'm left with is a 3. And that's equal to 1 times 4, which is 4, minus 2 times 3, which is 6, which is -2. In essence, what I did is I took the 1 times 4 and subtracted 2 times 3. So if I have 5, -1, 6, -2, that ultimately is just going to be -10 minus, because we're subtracting, minus -6, which is -4. Now this technique of multiplying like this minus that, this is the shortcut for a 2 by 2. Let's go to a 3 by 3. 1, -2, 4, -3, 6, 9, 8, 5, and let's make that 5 negative. To find the determinant here, I start in the upper left-hand corner, so that's equal to 1. This is finding the determinant. What I'm left with here, if I block out that row and column, is 6, 9, -5, 7. Minus, because I alternate signs, now to the next number, which is -2. We'll block out that row and column, and what I'm left with is -3, 9, 8, 7. Plus, because again, alternating signs, go to the next number, 4. Block out that row and that column. What I'm left with is -3, 6, 8, -5. This is 1 times, well, we have a shortcut now for the 2 by 2, so that's 42 minus -45, plus 2, the 2 minus signs make it positive, times the shortcut here, that's -21 minus 72, plus 4 times shortcut, multiply that diagonal, that's 15 minus that diagonal, which is 48. And so that is 87 times 1 plus 2 times -93 plus 4 times -33. So we end up with 87, -186, and 2, 1, 3, -132. These two give us -318, and then we add 87 to it, so I got a 1 and 23. So -231. Notice, ultimately what I ended up doing is that I did 1 times 6 times 7 minus 1 times 9 times -5. So I multiplied those together, and I subtracted that. Then I had minus -2 times this, so I basically ended up subtracting -2 times -3 times 7. I subtracted that product. And I added -2 times 8 times 9, so -2 times 9 times 8. And then I added 4 times negative 3 times negative 5, so I had 4 times negative 3 times negative 5. And I subtracted 4 times 8 times 6, which is that diagonal. So we have a shortcut here for determinants. 1, negative 2, 4, negative 3, 6, 9, 8, negative 5, 7. We'll find out if we made a careless error somewhere. If you're familiar with this, you can probably do this without having to rewrite the first two columns. What I'm going to do is I'm going to rewrite the first two columns, because for people who are new on this, that tends to help them. And first make sure that I have minus signs in the right spot. Should be the 2, 3, and the 5. 2, 3, 5, 2, 3, 5. Okay. I'm going to start in the upper right-hand corner, and I'm going to multiply those three numbers together. So that's 42. Then I'm going to multiply those numbers together. 144, so negative 144. Then I multiply those together right there, which is plus 60. Minus, going the other direction, I multiply those together. 192 plus that diagonal right there, that is negative 45. And then that diagonal right there, 6 times 7 is plus 42. This 102, so this becomes negative 42 minus here, that's negative 3, 189. So negative 42 minus 189, and lo and behold, negative 231. The same answer as we had before. Hooray, we did it right. The technique for solving a 3 by 3. And now we can do Kramer's rule.